Hello, Cardinals. We're going to talk about Lesson 6 Reflection today. You should be on page 60 in your notebook. And we're going to be revisiting our original focus question, which is how would a ball move if you threw it in space? Before we do that, we want to look back at investigation 6.2. That was where we had to use a fan card to get a tennis ball to move into the tape square. And we're going to talk a little bit about number 4, which was drawing a diagram in your notebook and using all the different arrows to indicate the directions of all the forces. And we're also going to look today at our objectives and give you a chance to write down how did you use Newton's third law of motion to in the tennis ball challenge. What were the action and reaction forces? As we go to our reflection today, we want to review our vocabulary words. You were responsible to get these in your notebook, but we just want to talk about them for a minute or two. Newton's third law is for every action, there is an equal and opposite reaction. These forces can also be called force pairs. And you can see the examples below with the hand pushing against the wall and the foot and the soccer ball. So every time a force is exerted on an object, the object exerts a force backwards. A couple more examples here. When we talk about balanced forces versus force pairs, balanced forces act on the same object, and force pairs act on two different objects. So you looked at the diagram of the hammer. You have the hammer is striking the nail, and the nail is striking the hammer. But when you look at the force pairs, it's acting on two different objects there. One last thing to talk about before we move on to the reflection is the mass of the ball affects what accelerates. So the mass of the ball is small enough that when you kick it, you can accelerate the ball. And your mass is too big for the force of the ball to accelerate your foot. So the mass of an object plays a role in how much an object is accelerated. As we move into the reflection today, we're going to be explaining the differences between action and reaction forces. And there are about, I think, 4 steps to this. Step 1 is you describing action and reaction forces when it applies to Newton's third law. And you want to focus on some of the highlighted things there, like what were the action forces during the investigations? What were the reaction forces at work in your fan car? And you're going to want to write your answers in your book. And you want to draw diagrams to support your information using arrows. The second one is going to be talking with your groups about your favorite sport or activity. And we're going to discuss how Newton's third law and reference frames apply to whatever your favorite activity is. Talking about the action and reaction forces, what makes the activity fun, what would it be like if the person involved, what's the activity like for the person involved versus the person watching it, thinking about reference frames once again. And we're going to talk about Newton's third law of motion. And then we're going to be making a poster on the back of the sheet that uses text and visuals to explain why this is a misconception. The misconception is that only unbalanced forces can change an object's motion. You need to think about that and explain why that's a misconception. And then finally, you have to read the physics on ice, and there are 3 questions to answer about that. So your to-do list today looks like this. You have 4 steps to do for lesson 6, including reading the physics on ice. And then you have a number of different articles that you can choose from to read when you get done. One is on propellers, one's on rockets, skiing, and then brakes. And don't forget that you do have access to your online textbook. So instead of reading them, you can always go online and listen to them. Have a great day, Cardinals. Please let your teacher know if you have any questions.